Today we're talking about factoring, and we're starting a bunch of different sections on factoring. Okay, so if I have the term factor, okay, what that means is a factor is a number that goes in to another number.
So it is a fraction.
A number that goes into another number. What I mean by goes into is I mean it divides. Okay, so if I just give an example right off the bat. Okay, let's talk about the number 10. If I talk about 10, I want to list the factors of 10. Factors of 10 is what multiplies to get 10 or what can divide 10. So a number I can pick is 1 because 10 divided by 1 is 10. Okay. Another number I can pick is 2 because 10 divided by 2 is 5. Can I pick 3?
No.
Can I pick 4?
No.
Can I pick 5?
Yes.
Because 10 divided by 5 is 2. It's a number, right? 6,
No.
7, 8,
No.
9,
No.
10.
Yes.
10 goes into itself one time. Okay. I want to do another example. Let's do 12. So talking about factors of 12. I'm going to show you a different way you can do it. Okay. Automatically, what always goes into a number? 1. 12 divided by 1 is 12. So 12 is another factor. Okay. Does 2 go into 12? Yes. 12 divided by 2 is 6. Does 3 go into 12? Yes. 12 divided by 3 is 4. And I'm done. Okay, that's another way you can do it. So 1, 2, 3, 4, 6, and 12 are all factors of 12. Okay, let's do one more. If I give you 24. Go ahead and try this one on your own. List the factors of 24. Okay, factors of 24. What's an automatic factor? 1. 24 divided by 1 is 24. So 1 in itself are automatically factors. Okay, every time. Does 2 go into 24? How many times? 12. Does 3 go into 24? How many times? 8. Does 4 go into 24? How many times? 6. We're done. Okay. Questions about the factors of single numbers. All right. Now we're going to talk about greatest common factor. Let's break this down. What does the term greatest mean?
Biggest.
The biggest. Okay, what does the term common mean?
Most. Frequent.
Like frequent, what they have in common. That's what it's saying. Okay? And then factor we said was a number that goes into another number. Okay? So, when we're talking about greatest common factor, we're talking about more than 2 numbers. At least 2 we're comparing. Okay? So, an example that I want to do is if I talked about the number 12 and 18. Okay? What we want to do is find the factors of both of those. Okay? So, factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, now we want to find the factors of 18, which are 1, 2, 3, 6, 9, and 18. Good. So now, when we're talking about finding the greatest common factor, we're going to pick from the list, what is the highest common number that they have in common?
6.
I hear 3 and 6. Which one should we pick?
6.
6, because that's okay. 6 is the greatest. Okay, so the GCF of 12 and 18 is 6. Okay, let's try another example. If I had 16 and 24. Let's think about ways that we can trim this down a little bit. Do I need to find both lists?
No.
Yes. I mean, you could.
I could. Okay. Which list is the most important, do you think?
Probably the 16.
Why 16?
Because it's the smaller one.
Because it's the smallest one. Okay. We're going to pick the smallest number to find the factors of, and I'll explain why here in a second. Okay. So the smallest out of 16 and 24 is 16. So the factors of 16, let's find them. 1, 2 is 3.
No.
Nope. So ways you can check, if I take 16 divided by 3 in the calculator, I get a decimal. So that means it is not a factor.
4.
Okay. 4, 8, and 16. Yep. So now, how can I see what's in common with 24?
Divided by 24 divided by 8.
Right. Do we want to take, so when we're starting to divide these, do I want to start at the lowest or do I want to start at the greatest?
Greatest.
Greatest, because we're trying to find the greatest common factor. So 24 divided by 16, yes or no?
No.
Can't do that. 24 divided by 8, yes or no?
Yes.
Yes, so my greatest common factor is 8. Now, you can try either one of these methods. You can find both lists, or you can find the smallest and then compare. Okay? Let's do one more example of these. $20 and $32. Find the GCF of 20 and 32. So, first I want to find the factors of which one's the most important? 20, the smallest one. Okay, so I'm going to find the factors of 20, which were what? List them.
4, 5.
Okay. Now, if you found the factors of 32, what were they?
1, 4, 7. No. 8.
2.
Yep, we missed 2. So 1 and 32 is 1. 2 and
4. No.
what's 32 divided by 2? Remember, you can use your calculators. It is 16. And then 32 divided by 4? 8. And then if you weren't sure about the rest, you can type in your calculator. If you get decimals, that means they are not factors. Okay? Those are all of our factors. So, if you did it this way, you would just compare the list. What is the highest common factor that they have? 4. Okay? If you use the other method, where you just found the factors of 20, okay, you would take 32 divided by 20, yes or no? 32 divided by 10. Yes or no? 32 divided by 5.
No.
32 divided by 4.
Yeah.
Okay, so you'll get the same answer either way. Does not matter how you do it. Okay? We are going to keep rolling with the same idea of greatest common factor, but I'm going to throw in algebra. Okay, so if I gave us x to the 5th and x to the 7th, I want to find the greatest common factor of those two terms. So let's break it down. X to the 5th, what does that mean?
X times itself 5 times.
So how many x's do we have in total?
5.
5. So I have x times x times x times x times x. X to the 5th is 5 x's multiplied together. Okay? Same thing. If I took x to the 7th, how many x's is that multiplied together? 7. So I have x times x times x times x times x times x times x. Okay? Still thinking about greatest common factor. So greatest common factor. What do they have in common?
We both have 5.
They both have 5 what?
5 x's.
5 x's, okay? If I compare it this way, they have 1, 2, 3, 4, 5 in common. So, is my answer, do you think, just 5?
No.
It,
X is 5 squared.
it's x to the
5.
5th power. That is our greatest common factor. Because they had 5 x's in common. So, x to the 5th is our greatest common factor. Okay, let's try another one. If I had x to the 8th and x to the 3rd. Again, if I take them all separately, what does x to the 8th mean?
X times 8.
X times itself 8 times.
So how many x's do I have?
8.
Yep. Yep. And then x to the 3rd means what?
X times itself 3 times.
3 x's. Yep. So, greatest common factor, how many do they have in common?
3.
Yep. 1, 2, 3. How do I write the answer?
X cubed.
X to the 3rd, x cubed. Now, what I want to ask you is, looking at both of those examples, what is a way that we could know what the answer is without having to do this?
It's
This
just
will be the
smaller
smaller one.
You always take the smallest one.
Always.
Every single time. You're always going to have the smallest one in common. Okay? So if I look at this example, x to the 5th and x to the 4th, what is the greatest common factor?
4.
X to the 4th because
It's smaller.
it's the smallest one. Yep. One more thing I want to talk about. I'll throw it in with an example. If I wanted you to compare x to the 3rd and x.
It's just going to be X.
It's just going to be X.
Because what's the exponent on that x value right here?
1.
1.
1. Okay, so for the GCF, you are still taking the smallest one, which is x to the 1st, or just x. Okay, so with variables, what they have in common is always going to be the smallest one. Okay? Okay. We're still talking about greatest common factor, but I'm going to mix them. Let's do, if I had 18 x squared and 40 x to the 4th. We're going to take it one at a time. So I'm going to look at the numbers first. Out of 18 and 40, which one should I find the factors of?
18.
18. So if I find the factors of 18, I have 1 and 18. What else?
18.
2 and
9.
9. 3 and
6.
6. That's it. So then I look at 40. Can I divide 40 divided by 18?
No.
No. Can I take 40 divided by 9?
No.
Can I take 40 divided by 6?
No.
No.
40 divided by 3?
No.
No.
40 divided by 2?
Yes.
So my greatest common factor for the numbers is 2. Is 2 my answer?
No.
I have to do the x's also, right? So in this one I have how many? 2. This one I have 4, so I need the smallest one, which is x squared. So our GCF of 18x squared and 40x to the 4th is 2x squared.
The other parts seem familiar.
Okay, let's look at another example of these. Let's do 9x to the 5th and 36x. That's it. 9x to the 5th and 36x. So I have 9x to the 5th and 36x. How do I find the GCF? What should I do first?
9.
We want to do the numbers first. So I have 9 and 36. Out of 9 and 36, which one should I find the factors of? The smallest one, right? Automatic factor.
1,
1 and 9. What else?
3,
3. Is there anything else?
no,
No. How do I figure out what the GCF is?
About 36 by 9.
Yep, take 36 divided by all of those. Okay, so 36 divided by 9, can I do that?
Yes.
Yes, so my GCF is 9. Yep, so now we look at the x's. Okay, how many do I have here? 5. How many do I have here? 1. Which one do I want? The smallest one. So my GCF is just 9x. Let's do another example. Let's do 12x y to the third and 36x squared y to the fifth. Now, just because I threw a y in there does not change anything. Keep that in mind. What should I do first if I want to find the GCF? Numbers first.
12.
Which one?
12.
12. Take the smallest one. What are the factors of 12?
1, 2, 2, 4, 3, 4, 6, 4.
Does everyone agree? Okay, what do I do next?
Divide them with 36.
See which one you could. Yep, if you don't, you could do that and then see what they have in common, but you could do this method also.
Divide 36 divided by 12.
36 divided by 12, yes or no?
Yes.
Yes.
3.
So my GCF so far is 12.
And then you look at
X,
the
Y,
x's.
Yep, how many x's do I have?
1,
1 and
2.
2,
So
so
I'm going to take the smallest one, so 1.
I need to take the smallest one, so I have 1 in common. What about the y's? I have 3 here, 5 here.
Take the smallest one.
Take the smallest one, which is
3.
3.
So if I did.
Sorry. The cubed has to go with the y. So if you wrote this, this 3 has to go with the y.
Why?
So this one's correct, this one is not.
with the x's because the y and the x are 2 separate.
Correct. The y and the x are not the same term. Okay, so you're looking at the x's separately and you're looking at the y's separately. Okay, let's do another example. If I have 28 x squared y and 35 x y to the fifth. I'm gonna change one of those. Do x squared on that last one. So 28 x squared y and 35 x squared y to the fifth. What do I want to do first here?
28.
What about 28?
Do you
Factors.
Find the factors. So I have 1 and 28,
2.
2 and
14.
14,
4 and 7.
4 and 7. Anything else?
That's it.
Okay. What do I do now?
Divide 35 by 28.
Yep, 35 divided by 28.
No.
No.
35 divided by 14.
No.
35 and 7.
Yes.
Yes. So part of our GCF is
7.
7. Now we take all the variables separately.
So I put x squared.
So x squared, those are the same, so they have each other in common.
Why?
And then y to the first, y to the fifth,
Why first?
just y to the first. Yep, or just y.
Because you want the lowest one.
I want the lowest one.
Wrong if we put x's and y's first before we do the number.
If you did this,
No, put the 7 last.
please put the number first. Please put, because this looks weird to me.
But it's not necessarily wrong.
It's not wrong, but please put the number first.
Sometimes when I'm working faster, I'll get this jammed.
Let's do one more example.
Mister, you have to like look at the variables like separately.
Yeah.
Like if
And we'll have to work on. And then are we done?
Yep. I have 6x y to the third, z to the second. And 9x squared yz.
So if it only has, okay, this is also another question.
What do I want to do first?
Find the variable, no. Find the numbers. The factor of the smaller one, which is 6.
Factors of 6, which are
1, 2, 3, 6.
1, 2, 3, 6. What do I do next?
Divide 9 by 6.
Yep, 9 divided by 6.
No.
9 divided by 3.
Yes.
Yes. So part of my GCF is 3.
3 X, Y, Z.
Okay. Now look x to the first, x squared, what's the smallest?
X to the first.
X to the first. Y to the third, y to the first.
Y to the first.
Y to the first. Z squared, z to the first.
Z to the first.
Z to the first.
3xy.
3xyz. Okay. One more that I got a really good question on is if I had like x squared, y, z to the second, and x to the fifth, y to the third. I want to talk about this one. There's no numbers we have to worry about this time, so we can jump straight into the greatest common factor of the variables. So here I have x squared and x to the fifth. What's the smallest?
X squared.
X squared. Here I have y to the first and y to the third. What's the smallest?
Y to the first.
Y to the first. Here I have z squared, but what do you notice over here?
No.
I have no z.
So you don't.
So what's the smallest?
None.
None. Okay, so I don't have any z in my greatest common factor. Because remember the word common. Okay? If I said my greatest common factor was this, that would mean that there should be a z in that second one.
Okay.
But since there's no z, that means there's no z in the common factor. Okay?